These are a continuation of notes 4.1. Today we're going to be talking about potential energy. So potential energy is different than kinetic energy. So potential energy is stored energy with the potential to do work. Okay, so work is just moving an object. So kinetic energy, remember, is the energy of anything in motion. Okay, so it is also measured in joules, just like kinetic energy. And so when an object is in motion, it has both kinetic and potential energy, okay, at least here on Earth. So the amount of each depends on the object's position. So if we see this ball, okay, as it's thrown upwards, because it's moving, it has kinetic energy, it's actually building potential energy, okay, because up at the top, it has more potential energy to fall back down compared to down here. We say it's on the ground, okay, it doesn't have very much potential to continue to fall because it's near the ground, okay? And then, so as it's moving up, the kinetic energy is slowing down, right? The object's going to be slowing down until it kind of stops up here where it reaches maximum potential energy. And then it's going to start falling again, so it's going to convert to kinetic energy and it's going to speed up. Okay, so the energy is converted between the two. Okay, so potential energy can be classified as different things. So there's three different ones we're going to talk about. So there's elastic potential energy. So this is stored energy by something that can stretch or compress. So some examples, which I didn't input here, but you can add in a text box. Some examples of this would be things like a rubber band, a bow and arrow, a trampoline. All of those are examples of elastic potential energy. So something is stretched, and then if the tension on that is released, it's going to cause it to move, cause kinetic energy to happen. Okay. The next one is chemical potential energy. So this is stored energy in chemical bonds. Okay, so when chemical bonds are broken, it's going to cause energy. So things would be like burning wood is an example of chemical potential energy. Also, batteries are an example of chemical potential energy as well. Right? And then number 3 is gravitational potential energy. And so we generally talk about this one quite a bit whenever we're talking about motion and physics. So this is the energy stored by objects that are above Earth's surface. So this example here was gravitational potential energy because it's higher from the ground. Okay, so we can actually calculate the gravitational potential energy for an object by taking the mass times gravity. Remember that gravity is 9.8 meters per second squared here on Earth, and then times the height of the object. Okay, so the greater the mass, the greater GPE it has, or the greater the height, the greater the GPE is going to be, the gravitational potential energy. Okay, so to do some practice problems, if we have a 0.06 kilogram tennis ball that starts to fall from a height of 2.9 meters, how much GPE does the ball have at that height? So we would take the mass, which is 0.06, times gravity, which is 9.8, times the height, which is 2.9. And we would find that our answer is 1.71 joules for the gravitational potential energy, GPE. For the next one, a 1.3 kilogram apple falls from a tree at a height of 7 meters. What is the GPE right as it leaves the tree? What's the GPE once it hits the ground? Okay, so we're going to find the GPE. So the mass of the apple is 1.3 times our gravity, 9.8, times our height of 7, and we'll get 89.18 joules. Okay. Then if we were to find what is the GPE once it hits the ground, our height is going to be 0. So our mass, 1.3 times 9.8 times 0, will give us 0 joules.